This is your code book. In this tutorial we are going to discuss about operators in Python. So if you know about the operators, we can easily write many programs using these operators. So before that, what is mean by operator? So operator is a symbol that is used to perform various operations. So look at this example, 8 plus 2. So consider this an expression. So here plus is the operator and 8 comma 2 are the operands. So generally operators are used to perform various operations on variables and values. So these are the types of operators in Python: arithmetic operators, bitwise operators, assignment operators, comparison operators or logical operators, identity operators, and membership operators. So arithmetic operators plus, that is addition, subtraction, multiplication, division, floor division, modulus and exponent. Bitwise operators are bitwise and, or, XOR, shift right, shift left and not. Assignment operators, that is generally assignment operator is used to assign the value to a variable, and plus assignment, that is these are the shortcut operators. In comparison operators, generally these comparison operators are used to find the relation between two numbers or variables. So the operators are equal to, not equal to, greater than, less than, greater than or equal to, less than or equal to. And logical operators are and, or, not. So and the next last two, identity and membership operators. So if you know any other programming language, these are the two new things in Python: identity operators and membership operators. So is not, in, not in. So let me explain one by one with example. So the first one, arithmetic operators. So as I told, addition, subtraction, multiplication, division, floor division, modulus, exponent. So first one, addition. So I am giving 8 plus 2, so the output is 10, and 8 minus 2, the output is 6. So 8 into 2, 16, 8 divided by 2, 4.0. So here we have a separate operation for floor division. So let me explain. 8 divided by 2, that is floor division by 2. So it will give the integer, the result is an integer. So in this floor division, always removes the digits after the decimal point. Okay, so this is the difference between normal division and floor division. In floor division, it removes the decimal point digits after the decimal point. And next, modulus. So 8 modulus 2, 4. Suppose if your input is 7 modulus 2, so the answer is 1. So 1 modulus 8, so the answer is 1. So the modulus operator returns a remainder of the division. And the exponent, so 8 exponent to 64, so 8 exponent 2 is equal to 84. So these are the arithmetic operators in Python. So addition, subtraction, multiplication, division, floor division, modulus, and exponents. So the program here, write a Python program to find area of circle. So open a new file. So the program name is area of circle. So in area of circle, the formula is area is equal to 5r squared. So we have to get the radius from the user end. So I am creating a object or is equal to int. Okay, so if you have any doubts related to this int function and input function, refer my previous video. So enter a number, so or enter a radius. Okay, that is a meaningful one. So enter a radius value, and then area is equal to, so 3.14 into r. So print area, comma, the result is stored in area. So save our program. So my program name is area. So you can see here area.py. So press F5 to run this code. So if you can see the interactive shell. Enter a radius value. If I am giving 1, so the area is 3.14. Again I am running the code. So my input is 2, so the area is 12.56. So this is about, so write a Python program to find area of circle. So these are the arithmetic operators. Let's move on to the next one. So bitwise operators. So the bitwise operators are AND, OR, XOR, shift right, shift left, and NOT operator. So again 8 bitwise and 2. So the answer is 0. So let me explain how this 0 generated by this expression. So X logical bitwise OR 2. So the answer is 10. Again 8 XOR 2. So and the answer is 10. And shift right. So 8 shift right 2. So the answer is 2. 8 shift left 2. The answer is 32. And the final one is NOT operator. So I am giving NOT operator 5. Okay, so the answer is -6. So these are the bitwise operators. So how these values are generated? if you see here, so 8 and 2, so bitwise operations. So before that we should know about how decimal value is converted into binary conversion. So in number systems we have 4 number system generally, decimal number system, binary number system, octal number system, and hexadecimal number system. So first I am going to explain about how a decimal value is converted into binary in a shortcut method. For example, here we have given the input is 8. So what is the binary value? What is the binary value for this 8? So it is 1 0 0 0. Okay, because in the code is shortcut code is 1 2 4 8. If I am placing 1 to this corresponding to 8, this binary, this 1 0 0 becomes 8. For example, one more example, if I am going to convert 12 means I am placing one first position and this second one, and rest of the positions are 0. So now if you see here, so this 2, so 8 plus 4 12, so that is the 12. Again, if you want to 7 means it is 0 1 1 1. So if you add these two values, 4 plus 2 6, 6 plus 1 7. So this is the decimal to binary conversion. So now in this example we have taken 8 and 2. So 8, so the binary code is 1 0 0 0, and the second operand is 2. So 2, the binary value is 0 0 1 0, and so the operation is 8 bitwise and 2. So here in AND operation, if both operands are 0, the output is 0, and here both operands 0 and 1, so the output is 0, again here 0 and here 0. So that's why what is the equivalent decimal value for this representation, that is 0. So that's why we got 0 in first one, 8 bitwise and 2, and next one is 8 bitwise or 2, and then output is 10. So here again, so 8 1 0 0 0 and 2 0 0 1 0. So now 0 0 0 and OR operation, 0 1 1 and 0 0 0 1 0 1. So this is 8 or 2. So what is the equivalent decimal value for this binary? 1 0 0. So according to this shortcut, you can see this first value is equivalent to 8 and here 0, and this one is equal to 2. So 8 plus 2 10. So this decimal value for this 1010 is 10. So look at our output, the value is 10. And the next one, XOR operation. So again 8, so 1 0 0 0 2 0 0 1 0. So the operation is 8 XOR 2. So in XOR, the truth table is if the input values are different, the output is 1. If the input values are same, the output is 0. So here 0 0, so 0 and here 0 1 1, here 0, here 1. So what is the equivalent decimal value for this binary representation? 1 0 1 0, again it is 10. So that's why we got 8 XOR 2 is equal to 10. So this is about the first three operators and bitwise and or XOR. And next one, shift right 8, shift right 2. So here the shift right, we have taken the value is 8. So the number is, I am going to represent using 8 bits. Okay. So here 0 0 0 1. Okay, and again 0 0 0 0. So I am representing this binary decimal value 8 into 8-bit binary representation. So now the operation is 8 shift right 2. Okay, so shift right 2, so the number of bits shifted by right by 2. So here I am move this 0 to the first position and again moving this 1 to second one. Similarly rest of the values. So now this the first position filled with 0 and the second position filled with 1 and 0 0 0 0. Okay, so here the 5 6 so shift right by 2 bits, so 0 1 okay, so this 0 moves to here, this position, and here this one, here this 7 moves to here. So we will get 2 empty position that filled with 0 0 0. So now tell me what is the decimal value for this binary representation. So this binary representation is 2. So that's why we got 2. Okay, so 0 1 2 4 8, that is using this code 1 2 4 8. Okay, 8421 code. So again we have a formula to find the value in the shift right. The formula is x divided by 2 power I. So x is the actual number, I is the number of bit positions we are doing shift right operation. So here 2, so 8 divided by 2 by 2, 2 power 2, so the answer is 2. So try this one. So 12 shift right by 2 bits. Okay, so what is your answer? So find the answer and write it down comment section. And the next one, shift left. So shift left again 8 shift left by 2 2. So again I am copying the same things here, the representation. So here the operation is 8 shift right by, sorry, shift left by 2 bits So here this one comes to, so fifth position value comes to the seventh position because shift left by 2 bits, and here this fourth one comes to sixth position. Okay, so now these values are 0 0 and again here 1 0 0 0, and we have two empty positions, that field is 0. So now what is the value of this binary representation? Okay, if you are using this 8421 code, 1 2 4 8 16 and 32, we have only one position in that value 1, so this one is equal to 32. So this is we got in 8 shift left by 2 bits 32. Again we have a formula to calculate this shift left output. So x into 2 power I, so x is the number and I is the number of bit position. We are doing shift left operation, so 8 into 2 power 2, so the answer is 32. And now again one more example, 12 shift left by 2. So find your answer and write it down comment section. And next one is about not operator. Okay, so I am giving this not 5. So generally before that we should know about this representation, number representation, 1's complement and 2's complement. So 1's complement is, for example, if I am taking 5, so the representation is 0 1 0 1. Okay, so 4 plus 1 5. So what is meant by 1's complement? Converting zeros to ones, ones to zeros is known as 1's complement. So here it is 1 0 1 and 0. So this is the 1's complement of the number 5. And the second representation is 2's complement. What is meant by 2's complement? So after finding the 1's complement, add 1 to the result of this 1's complement, that is the 2's complement. For example, let's take the same example, 0 1 0 1. So what is the 1's complement of this one? We know that 1 0 1 0. So this is the result of 1's complement. Now we are going to add 1 to this result of this 1's complement, and 0 plus 1 1 1 0 1. So this is the 2's complement of the decimal value 5. So here this 1010 is the 1's complement of this decimal number 5, and this is the 2's complement of decimal number 5. So let's work out this not operation, that is not operation of 5. So the output is, we got -6. So here, so the representation is 0 1 0 1. So the complement is converting zeros to ones, ones to zero. So we got 1 0 1 0. So this is the equivalent to -6. So in number representation we have two things. One is the LSB and MSB. So LSB is the least significant bit 0 and MSB is the most significant bit. In computer, every positive number, this MSB bit is equal to 0, and negative number, this MSB bit, that is most significant bit, is 1. So here if you want to this is the representation of -6. To check this value, whether the given we got the value that is 1010 is the -6, just takes the 2's complement of that -6. Okay, let me write. So -6, its representation is 1 0 1 0. If you convert this, take the 2's complement of the result, we will get +6. Let's check. So first one, take the complete the 1's complement. So 1 becomes 0 and 0 becomes 1, 1 becomes 0, 0 becomes 1. So now add 1 to this result, that is 2's complement. So 1 plus 1 0, that is binary addition. In binary addition, 1 plus 1 is 0, that is sum is 0, carry 1. So the carry should add it to next higher order. So here 1 plus 0 becomes 1 1 and this one is 0. So this is the equal to, sorry, this one is equal to +6. Okay, so we know that from this concept, okay, we can say this 1010 is the -6. Okay, because from this one we got +6. So here look at the MSB bit. In -6 the MSB bit is 1, in +6 the MSB bit is 0. So this is the so NOT operation of 5 produces -6. Okay, so this is the bitwise operators. So the bitwise operators are AND, OR, XOR, shift right, shift left and NOT. And here the example program is to implement shift left operation. So let me write the shift. So we will read the one number from the user end. Input, enter a number, and n is equal to n shift, the same thing we will take, okay, 2, shift left by 2, and then print the result, print after shift left the n value comma n. Okay, so I am saving this program. So the program name is SL, okay, shift left dot py. So the program is shift left dot py. So press F5 to run this script. So enter a number here. So I am going to type the same, okay, so 8, and then we will get 32. Okay, so this is the example program for shift left operation. So that's all about bitwise operators, AND, OR, XOR, shift right, shift left, NOT. And the next one is assignment operators. So basically this assignment operator is used to assign a value to a variable. So and then we have a few shortcut operators. So plus, that is first one add and assign, second subtract and assign, multiply and assign, division and assign, floor division and assign, modulus and assign, and exponent and assign. So for example, if I am giving x is equal to 8, so x plus is equal to 2. So then if you are pressing X, you will get 10. So similarly you can do rest of the operations: subtract, multiply, division, floor division, modulus and exponent. And what is the example program? That is, the example program is to find the exponent of a number. So let me create the program. So exponent of a number using this shortcut assignment. So the program name is exponent of a number. So I'm going to read two inputs from user end. So first one, X integer, enter a number, and the second one for exponent, okay, integer input, enter exponent value. Now I am doing this exponent operation, X in short, X Y. Okay, so print result Z. Okay, so using Control S, I am going to save this program. So exponent, so use F5 to run the script, enter a number, so 8, and exponent value is 2, the result is 64. So this is the Python code for exponent of a number. So that's all about assignment operator. And the next one is comparison operator. So comparison operator or relational operators. These comparison operators are used to mainly compare the relationship between two numbers or two values or two variables. So the operators are equal to, not equal to, greater than, less than, greater than or equal to, less than or equal to. So for example, if I am giving 8 equal to 2, so false. Always these operators generates boolean values, either true or false. It depends on the expression. Or here 8 is equal to 2, so the condition not satisfied, so here the false, the return value is false. If you are giving 8 not equal to 2, so the return value is true. And similarly 8 greater than 2, so return value is true. 8 less than 2, false. 8 greater than equal to 2, it is true. 8 less than equal to 2, false. So these are the comparison operators in Python. So the program is, write a Python program to find the largest of two numbers. So the program is largest of two numbers. So I'm going to read two input values from the user end. So x is equal to int input enter first number so I'm copying paste the same second line y. So int input enter second number. So later I will explain about these conditional statements. So if we are going to compare these two numbers, so x greater than y colon, okay, so every if statement must end with colon. If the condition is satisfied, we can say the x is a largest number. Okay, else we can say again the else statement also should end with semicolon. So we can say if another possible is the y is the largest number. Okay, so save the program. Okay, so file name is largest.py. if you are using fi, you can run the code. So first number I am giving 8, the second number is 2, so 8 is a largest number. So again to check the another case, I am running the code again. So now the first number is 2, the second number is 10, so 10 is a largest number. Okay, so if you are using this kind of conditional statement, check the all the possibilities. Okay, so here first case I have given first number is 8, second number is 2. In second case, first number is 2, second number is 10. So all the possible two possibles are working here. So this is about the largest of two numbers. So comparison operators: equal to, not equal to, greater than, less than, greater than or equal to, less than or equal to. And next one is logical operators. So here the logical operators generally used to compare the more than one expression. So the operators are logical and, logical or, and logical not. For example, I am giving 8 greater than 2. This is my first expression. And okay, so the don't use the symbols. Okay, so in some other language we will use 2 ampersand symbol. Here the keyword is and 10 greater than 2. So here both conditions are true. So 8 greater than 2 evaluates to true, and 10 greater than 2 also evaluates to true. So the output is true. Suppose I will change this condition. So 10 less than 2. Now you will get the output is false, because the first expression is evaluates to true and the second evaluation evaluates to false. If any one of the expression evaluates to false, then the final return value is false. This is about AND operator. And OR operator, again the keyword or, here the true, because any one of the condition is satisfied, the return boolean value is true. Here 8 greater than 2 is true and 10 greater than 2 is false. If any one of the expression is evaluates to true, so the final return value is true. And then the third one is not. So not of, if I am giving 8 greater than 2, so the output is false, because so the 8 greater than 2, that expression evaluates to true, and this not logical operators invert the result, so true becomes false. One more example, not of 8 less than 2. So now the output is true. So this is about the logical operators. And then program is to find the largest of three numbers. Okay, to find the largest of three numbers. I am giving a new file. So I am copying this one, this similar to this one. So largest of the program name is largest of three numbers. So we have to get three numbers. So x, y, enter third number. So the variable name is set. So x and y and x greater than set. So if both the conditions are satisfied, okay, so we can say x is a largest number. And then here L if, okay, so later we will discuss these conditional statements. L if we have another condition, y greater than z. If the condition is true, we can say y is the largest number, else we can print z is the largest number. So save the program. So largest, okay, I can give largest 3. Okay, so three numbers. So we are reading three numbers, and if statement we are comparing x greater than y and x greater than z. If both the conditions are satisfied, we can say x is the largest number. L if y greater than z. Okay, so from the first observation we can say x is the smallest number compared to y and z. Okay, and finally in L if we are comparing y greater than z, if the condition is satisfied, we can say y is the largest number or else z is the largest number. So use F5 to script run the code. So 10, 1, 2. So 10 is the largest number, and again I am running the code. So now this time my second input is high, so 10 is the largest number, and again third possibility. So 1, 2, 3. 10 is the largest number. Okay, so all the possibilities are working here. So this is about write a Python program to find largest of three numbers. So the logical operators are and or not. And next one is identity operators. So the identity operators are used to compare the memory location of two objects. So we have two operators. One is, the another one is the is not. So the meaning of this operator is these operators all again always returns either one of the boolean value, true or false. It returns true if both the variables are the same object, and is not returns true if both the variables are not the same object. Let me explain here. So for example, I am giving here x is equal to 10, x is equal to 10 and y is equal to 10 and z is equal to 20. Okay, so now x is y. So the answer is true. Okay, so that meaning is the return true if both the variables are same object. Okay, so x and y are the same value, so x is y is true. Suppose x is set, then the output is false, and again x is not y, this is false, and x is not z, the true. Okay, so how these boolean values generated by this is operator. So we know we have a function id to find the identity of an object. Okay, if you are using id of x, so look at the value, and again id of y, and look at id of z. Okay, so here, so x and y are the same locations. Okay, so because x value is equal to 10, y value is equal to 10. So these identity operators are used to compare the memory location of two objects. Okay, so from these examples we can understand this is and is not operator. So write a Python program to implement identity operators. So open a new file. Okay, so the program name is identity. So we are reading two input values. Okay, so if x is y, we can say id of a is we can say id of a is same as id of b, right? And then else we can say id of a is not same as id of b. So save our program. Okay, so program name is id. So use F5 to run the code. Enter the first number, I am giving 10, and second number also I am giving 10. So you can see the output. id of a is same as id of b. Again I am running the code again. So now this time I am giving first number is 10 and second number is 20. You can see id of a is not same as id of b. So this is the identity operator. So identity operators are used to compare the memory locations of two objects. So is not. And the last one is the membership operators. So the membership operators, from the name itself we can say whether the value is present in the sequence or not. Okay, so list, tuple or anything. So and the two operators are in, not in. So returns true if a sequence with the specified value is present in the object, and the second operator is not in. Returns true if a sequence with the specified value is not present in the object. So let me explain the example. So I am creating one list. Okay, so numbers 1, 2, 3, 4, 5. So this is my list. Okay, so nums, and for example 1 in nums. Okay, so you can see the return value is true because the 1 is present in the sequence, that is a list. Suppose I am giving 10 in nums, so the output is false. So again, so 1 is not in nums, so the return value is false because 1 is present in the list, and 10 not in nums, so the value is true. So this is the the use of this membership operator. So the membership operator used to find whether the element is present in the sequence or not. So the example program is to implement membership operators. So Alt F, new file. So the membership. So I'm going to create one list. Okay. So similar operation you can do with tuple also. Okay. So 1, 2, 3, 4, 5. This is my list, and next I'm going to get the input value from the user end. So input enter a number, if so x in list, okay, nums, then we can say x is present in the list, or else print x is not present in the list. So this is our program. Save our program. Okay, mgmpr number. Okay, so the file name is member.py. If you are pressing F5, enter a number. If I am giving 3, so x is present in the list. Running the code again. If I am pressing 10, the x is not present in the list. So this is about membership operators. So in and not in. Okay, so practice these programs. Write a Python program to swap two variables. Write a Python program to convert Celsius to Fahrenheit. So far we have discussed various types of operators in Python. So the operators, the types of operators are assignment operator, bitwise operator, arithmetic operators, comparison operators, logical operators, identity operators, and membership operators. So thank you.